Hi friends, welcome to Pen and Pencil. In this video, we will learn about the basic proportionality theorem, which is also known as Thales Theorem. What does the theorem say? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. It is very important to understand the theorem first before moving on to prove the theorem. Only when you understand the theorem, it will be very easy for you to prove the theorem. So, what does the theorem say? If a line is drawn parallel to one side of a triangle. We will divide this sentences so that it will be easy for us to understand. Okay. So, I have divided this first. If a line is drawn parallel to one side of a triangle. As you all know, a triangle has three sides AB, BC and CA, and it's saying if a line is drawn parallel to one side of a triangle, that means I can draw a line parallel to any side of a triangle. For example, I can draw a line parallel to BC like this, or I can draw a line parallel to AB like this, or I can draw a line parallel to AC like this. So, we can draw a line parallel to any side of a triangle. Okay. So, for our better understanding or for the easier way, I will go on to stick with a line drawing parallel to BC. Fine. Next, it's saying to intersect the other two sides in distinct points. Okay, I will divide further here. The other two sides, what are the other two sides? That is, I have drawn a line parallel to this one side, that is BC. The other two sides are AB and AC. So, it's saying to intersect the other two sides in distinct points. That is, this line is intersecting AB at, let me name it as D. Okay, and it is intersecting the side AC at E. Okay, is it clear? This line which we have drawn parallel to one side of a triangle is intersecting the other two sides, that is AB and AC in distinct points, that is the distinct points we have named as D and E. Okay, similarly here we can name as it is intersecting AC at D and it is intersecting BC at E, and here it is intersecting AB at D and BC at E. Okay. So, this is what it is given to us. If a line is drawn parallel to one side of a triangle, we have drawn a line. Okay, let us say this line as L. Okay, so we have drawn a line L parallel to BC, that is a one side of a triangle, to intersect the other two sides in distinct points. So, that is it is intersecting AB at D and AC at T. So, these are the other two sides of a triangle. Then it's saying that the other two sides are divided in the same ratio. The other two sides, that is AB and AC, so these are divided in same ratio, that is AD upon DB. This is one ratio, and AE upon EC, this is the other ratio. So, it's saying it is divided in the same ratio. That means these ratios are equal. So, we have to prove that these ratios AD upon DB and AE upon EC are same. That means they are equal. So, this is what we are supposed to prove in this theorem. So, let us move on to what is given. Okay, we are given a triangle ABC. Okay, and where DE is parallel to BC. And what we are supposed to prove, that the ratio of the other two sides, that is AD upon DB, is equal to AE upon EC. Now, before moving on to proof, we have to do some construction. So, to explain the construction in detail, okay, I have to make you understand why we have to construct. Okay, without constructing we cannot move on to the proof. So, what are those constructions and why we have to construct, I will explain you here. Okay, so first and foremost, understand that this entire theorem is based on area of a triangle. Okay, let me write down. The area of triangle is equal to half into base into height. Okay, and always observe what we are supposed to prove. I have written down here what we are supposed to prove, that is AD upon DB is equal to AE upon EC. Now proof of the theorem is based on area of triangle. So when we have divided this triangle with the line DE, so this triangle is divided into two parts. Okay, the first is ADE, okay, and second is BDE and C. Let me write down those two parts, that is ADE is the first part and BDEC is the second part, right? So when you look at this first part ADE, it is already a triangle, because for the area of a triangle obviously we need a triangle. So this is already a triangle. So we should have bases and we should have heights, because when you look at two proof, okay, here we have the sides AD and AE. So we can consider AD as one base of a triangle and we can consider AE as one base of a triangle. But where is the height? Okay, so we have to do something to construct a height. So here we will be constructing the height. So what I will do is I will join a perpendicular from the point AD on the side AE and I will name that as M. In the similar way, I will draw a perpendicular from the point E on the side AD and I will name that as N. Okay, what we have constructed is we have constructed the perpendicular EN and the perpendicular DM. So therefore we have the bases as AD and AE and we have the heights as DM and EN. So this the first part of the triangle with the help of a area of triangle. So our first part is done, right? Our first part is done. Now coming to the second part, that is BD, E and C. Where do you find a triangle? It is a figure with the four sides, right? So but where is a triangle? So there is no triangle here. But when you look at two proof, we have DB and we have EC. That is, this is the DB and this is the EC. So what we have to do is we have to make this DB and EC as a part of a triangle, right? Or rather we have to make this as a base of a triangle. Okay, because already we have drawn the perpendiculars. So what we can do is we can join BE and we can join DC. So now we have the triangle BDE and we have the triangle DE and C, right? So I will write that down. So what we have constructed here is we have drawn a perpendicular DM on the side AE and we have drawn a perpendicular EN on the side AD. And the next construction is we have joined BE and we have joined DC, right? So now we have four triangles. What are those triangles? In the triangle ADE, we have two triangles with base AD and with base AE, and we have triangles BDE and DEC, right? So we have constructed two things here. Draw EN perpendicular to AD and DM perpendicular to AE. And what is the second construction? We have joined, that is we have to join BE and CD. So these are the two constructions. So did you understand why we have constructed this? Because I have made it very easy for you to understand. See friends, always you have to follow some method or some logic or something which is very easy for you to understand later on, or when you look at this theorem, it will help you to prove or it will help you to remember for a longer time. Okay, so that is why I have made these things easier. So I have told you that this proof of this theorem is based on the area of triangle, that is half into base into height. Okay, so when you look at two proof, okay, where you have the sides AD and AE. So we have divided this triangle with this line DE. Okay, so when you look at the sides AD and AE, we already have the two bases, but there is no height. For the height, we have drawn a perpendicular DM and EN. And when you come to the second part, that is the DB and EC, so we have the sides DB and EC, but there is nowhere a triangle to be seen here. Okay, so that is why we have joined BE and DC, so that we'll have triangle with base DB, and we already have a perpendicular drawn from the vertex E, that is EN, and in the triangle BDE we have a perpendicular drawn from the vertex E, that is EN. Now coming to the proof, as I told you before, this proof is based on the area of triangle, and we'll write that down here. This is a step 1. Area of triangle is equal to half into base into height. Now we have 4 area of triangles, and we'll write those down here. So first, area of triangle ADE. So here we'll take the first base as AD. So when the base is AD, the height is EN. Okay. Next, the area of triangle ADE. So here the base is AE and the height is DM. Next, the area of triangle BDE. So the base is BD and the height is EN. Next, the area of triangle DEC. The base is EC and the height is DM. So this is our first part. Okay, this is our first part to write down all the areas of triangle. Now when you look at this to proof, okay, so this is in the ratio form. Okay, so we have to arrange these area of triangles in this manner. Okay, so we'll do that. This is our second step. So area of triangle ADE is equal to half into AD into EN. Okay, so here we have AD, right? Here we have AD and here we have AD. So next is DB. So DB, that is nothing but BD. Okay, so we'll take that area of triangle here. So area of triangle BDE is equal to half into BD into EN. So here this half gets cancelled and EN gets cancelled. So we are left out with AD upon BD, and we'll take that as our result 1. So the next ratio area of triangle ADE is equal to half into AE into DM upon area of triangle DEC is equal to half into EC into DM. So here half gets cancelled, DM, and then we are left out with AE upon EC, and this will be our second result. Okay, so we have 2 parts here. So this is the first part to list down all the areas of triangles, and the second part is to arrange these areas of triangle in a ratio manner. Okay, so now when you look at these 2 triangles BDE and DEC, what do you recollect or what do you remember? So in your previous class you have studied that the triangles lying between the 2 parallels and on the same baseline, their areas are equal, right? That means the area of triangle BDE and the area of triangle DEC are equal because they lie on the same base and between the same parallels. Therefore, what I can write as, but area of triangle BDE is equal to area of triangle DEC, and we write the reason that triangles on the same base and lie between same parallels, between same parallel lines are equal in area, right? Therefore, what I can do is, I can replace this area of triangle DEC with area of triangle BDE in our second result. So, replace area of triangle DEC with area of triangle BDE in our second result. So, what do we get? Area of triangle ADE upon area of triangle BDE is equal to AE upon AC, and this will name as our result 3. So, when you look at the results 1 and 3, our left hand sides, that is area of triangle ADE upon BDE, this is also area of triangle AD upon BDE, right? So, this left hand sides are equal, therefore, the right hand sides are equal, that is AD upon BDE is equal to AE upon EC. So, this is what we were supposed to prove. Understood? So, this was our first steps here to list down all the triangles. Okay. So, first what we have done is we have listed down all the area of triangles, and then we have formed these area of triangles in a ratio manner, and then we have got the results 1 and 2. But the area of triangle BDE and DEC are equal because they lie on the same base and between the same parallel lines. Therefore, we have replaced area of triangle DEC with area of triangle BDE in our second result. So, what we get is our left hand sides will be equal when you look at the first result and the third result. So, when the left hand sides are equal, the right hand sides are automatically equal. So, therefore, we have proved.